Hey y'all, today I'm going to talk about my applied project, which is a DSL for climate data visualization. So I will talk about the problem statement, what is a DSL, what are the examples, what are the advantages and disadvantages, and then we'll talk about my project further. So the problem statement is weather data are big data that are extremely large in volume, variety, and velocity. Their complexity has made it difficult to collect, process, interpret, and understand data by a traditional program or general user. Whether data visualization is a useful and effective tool for data extraction and visualization for better analysis and assessment of data. This project will attempt to develop a weather data visualization model by developing a domain-specific language specified to weather data. This DSL will be developed by using Python 3 programming language and other tools and materials. So first of all, what is a DSL? DSL stands for Domain Specific Language, which is an advanced language specified for domains. Domain-specific languages are languages which capable of performing specific tasks according to their domain. It is more formal way to implement solutions to many problems. As you may be familiar with general programming languages such as Java, C Sharp, those are tools that can perform many tasks or solve many problems. But DSLs are specific tools which good enough to solve limited set of problems for a specific domain. DSLs uses a suitable syntax to read the domain language, and that offers loop structures, makes the data abstraction easy, accesses all description of the model, allows flexibility when adapting to architectures, and there are many more. So what are the real world DSL examples? DOT for define graphs, SQL for creating databases, HTML for developing web pages, and CSS for styling web pages. XML is used to data encoding, decoding, and pass data across different platforms and different languages. UML is used for visual modeling, VHDL for hardware designing, LaTeX for document layout, and there are like many more DSL examples, useful DSL examples in our real world. And as an example, let's say if you're a database engineer, you're going to use SQL to create a database. First of all, you will use UML for designing the database and create the relevant drafts, and then we'll use SQL to create database and insert data and retrieve data from it, or create stored procedures and all. So it that makes your life easy. There should be advantages in DSL, right? So otherwise there is no point of creating a DSL. So there are like many advantages. The first thing is easy to analyze. Can you guarantee your program will terminate? Let's say you create a program, it might end up with an infinite loop, right? So DSL will handle all those cases, and it is safer to use. You just can't have null point exceptions or array index out of bound exceptions, right? But DSLs handle those corner cases, and it will throw meaningful errors. So it will throw meaningful errors that those errors speak the domain language itself. It's easy for domain expert to understand, and it is easy to port, capture knowledge, and make easy to port it another technology. And the other main thing is easy to learn. You just need to have domain knowledge. You don't need to have a 6 months course in programming. If you have domain knowledge, that's enough. And because those syntaxes, grammars, errors, all are domain specific, and it is easy to learn, it's to identify. And the other main thing is the DSL speak itself for domain experts, hides the technical details and its implementation, and expose only the information that domain experts can understand. So what is the data visualization? Data visualization is an efficient and powerful technique in big data analysis which allows people to understand, identify, read, and compare scientific data in more accurate and meaningful manner. Having a graphical representation instead of textual representations would be more helpful as the human brain can process visual elements faster than textual elements. However, visualizing large data into a graphical representation is more challenging task for a normal user. Even a good programmer won't be able to understand or read scientific raw data and use them to visualize a meaningful graphical representation at the first glance. In this project, I'll be developing a climate data visualization model, which is a graphical representation of weather data. In general, weather data are usually scientific big data that are not user-friendly or readable and complex to use in regular manner. To obtain multidimensional graphical output using these data will require special and sound knowledge about scientific weather data patterns as well as programming knowledge. I'm intending to develop a user-friendly tool using DSL which make it easier for any user to read and interpret data. So see, this is a climate raw data. It's a NetCDF file. It has global variables and its own variables and thousands of lines of data. And it's so hard for you to understand by looking at this, and it's so hard to extract anything from by looking at this. So here, this is my main user case, and I have 5 to 6 cases. So the main target audience is programmer, whether data scientist, and big data analysis. So there are like 5 modules as a first version. View a quick plot, view sounding plot, view total pressure diagram, view wind speed diagram, and store manipulated data in a new NetCDF file. And also programmers can update or enhance DSL. They can add more modules and make it useful. And this is a sequence diagram. So DSL user going to be created a source file, and the source file will be used by DSL compiler, and it will compile and check any syntax errors are there. If there are any syntax errors, it will throw domain specific errors, and user needs to solve those errors and again run it through DSL compiler. And DSL compiler will check the module and import necessary modules, and then call the module, and the module will use the data, and it will retrieve the raw data and perform all the validations and also perform calculations and mathematical equations and produce or generate a diagram. So this is a class diagram. It's a simple diagram. The main thing is climate data visualization DSL class, and that contains several methods which is import module, load module data, call module, perform validations, show validation messages, get arguments, and rest of all the class diagrams are same, only the methods is change. This is a DSL design. See the traditional design and proposed design. Proposed this DSL will group all the data processing, library, format, data generation of visualization. It will make as a DSL, and it only needs a raw data, and it only needs a source file, and it will provide the output. So this is a proposed DSL architecture. So user needs to create the source file by using DSL syntaxes and grammars, and needs to provide raw data in NetCDF file, and it should pass through the DSL compiler. DSL compiler has a code analyzer, so it will go through the code analyzer first. It will analyze the code and check any syntax errors are there or not. If there are any syntax errors, it will throw domain specific error messages for the user. If everything is okay, then it will pass to the data processor. Data processor will use the raw data, and it process and do all the calculations and mathematical equations and all, and it will create a 2D array output data. So that array will be used by data visualization generator, and that module will use matplotlib in Python modules, and then it will create and display the right output. And that's it. Thank you for your time, and if you have any questions, please feel free to create a comment on my YouTube link. Thank you.